inkling that they were parallel. Okay, one application of slope is finding the rate of change of something. This example gives us a hang glider who starts at 7:55 a.m. and travels at a constant speed. He covers the distance as shown on the table. If you plot these points on the coordinate plane using time as the x-coordinate and distance as y, so time, this is our x and this is our y. What is the correct interpretation of the slope of the line connecting the 2 points? So here are his times, 8:30 a.m. and 9 a.m. Here are his distances traveled. What this gives us really are 2 points. Okay, the point 8:30 and 12 miles, and the point 9 a.m. and 36 miles. Now, what we're discovering here is his change in distance compared to his change in time, or his miles per hour. Okay, so here are the miles, and here are the hours. Now, remember, when we find the slope, we want to do y minus y on top, okay, or the change in distance. So that would be 36 minus 12 on top. That's our y's. The change in x's on the bottom. Well, when we think about this, what's the change from 9 a.m. to 8:30 a.m.? That's 1/2 hour, right? So on top we have our miles, 36 minus 12. Gives us 24, and on the bottom we have 1/2, which I'm going to write as 0.5, okay, half of an hour. 24 divided by 0.5 is 48. So what does this stand for? This stands for the speed of this hang glider. He is traveling at 48 miles per hour. So again, we subtracted the distance on top, the times on the bottom to find out how much time had changed, and we divided the distance divided by the time. Okay, here we have an example of an inline skater's distance traveled over time. Okay, from the graph, can you tell that the skater's travel is at a constant speed? We can, because notice there's no changes in this line. It's constantly going at the same rate. Okay, dividing distance by time gives the speed. Which is the same as the slope of the line? Okay, we want to find his speed. So we want to take distance divided by time. Okay, now we want the change in distance here. So notice they gave us 2 points here. They gave us the point, this is between 2 and 3, so it's 2.5. And the distance is 35. This one is between 1 and 2. It's at 1.5 and 20. Those are our 2 points. So what we're doing here is finding the slope of the line. We want the change in distance. Okay, so again, this is just like our slope formula. We subtract the y's. So my y's were 35, my distances, minus 20. My time was 2.5 hours and 1.5 hours. 35 minus 20 is 15, and 2.5 minus 1.5 is 1. 15 divided by 1 is 15. So the speed of this inline skater is 15 miles per hour.